Welcome. Today we're going to be talking about linear equations, that is a key concept in algebra. This will be really helpful for you to complete in many areas of math, even in the real world. How are you feeling about algebra so far? Don't worry, I'll be covering a couple of things that will help you on the way. So the topics that I'll be covering today are what are linear equations, how we're going to solve them, so there'll be a step-by-step guide, and a couple examples, and some of them on your own. I'll be checking in with you along the way to make sure that everything's clear. Feel free to ask any questions at any time. Understanding linear equations. A linear equation is technically an equation in the form of ax plus b equals to c. Remember, the linear equation is a straight line equation, which you'll see often on the graphs when you're drawing in regards to linear equations. Now we'll dissect a couple of equations so you understand the structure a bit better. Your general formula is ax plus b equals c. So, what we consider your consonants is b and c. And your a is your coefficient. Your variable is x. Your variable is the one that you're solving for. So x is your mystery, the one that you'll be often solving for. And don't forget, this is your operation. So a variable is a symbol for a number that we don't know yet. The one that you're finding. It's usually the letter x or y. It could be a symbol or a word. But mostly in linear equations or algebra in general, it will be often x or y. But there are likely times that they would use different letters to indicate what you're solving for. The number on its own is a constant. Sometimes the a could be a constant, but it's very rare to find that. So the numbers by itself is the constant. Now coefficient is the number that's been multiplied by the variable. So it's a multiply x. So that means ax means a times x, so that the a is the coefficient. The one that's often multiplied by the letter. Now variables on their own, without a number next to them, have a coefficient of 1. X could be sometimes 1x, but that's only if it's by itself. You'll see sometimes a coefficient that is a letter like a or b instead of a number. Now you have this example, ax to the power of 2 or ax squared plus a or bx plus c. The variable is this x, and a and b are the coefficients. And the c is the constant. Remember, the constant is the one that doesn't really change much. It's the one that stays the same most of the time. The operator, as you all know, is the symbol. So, operators often go by plus, minus, times, and division. So your basic operations. It tells us what to do with the value. Now the terms. This is another way to show a bit further of understanding. Now I'll give you another example. 4x take away 7 equals 5. Now all of these are terms. A term is either a single number or a variable, or numbers and variables multiplied together. An expression, which is 4x take away 7, is a group of terms. Usually the terms are separated by either a plus or a minus sign. So, expression, remember, is often between two terms that is separated by two operations that are either add or minus. And the term is usually the ones that are single variable, numbers, and variables that are multiplied together. Now that we have an understanding of linear equations, we'll move on to the next slide. Graphing linear equations. We won't be doing that this lesson, but we will learn how to do it step by step in the next couple of lessons. Now, graphing a linear equation provides a visual representation of the relationship between the variables. The line created by plotting the solutions will reveal the intercepts and the slope. That is the essential concepts in understanding what the linear relationships are. Now, solving linear equations. To solve a linear equation, we have to isolate the variable by performing inverse operations. This will be involving moving the constants from one side to another, or to have it onto one side and the coefficients to another. We'll walk through a couple of examples to practice these techniques to build your confidence in solving these questions. Now, what are inverse operations? Inverse operations are used to undo each other. It's a mathematical operation. You will understand it a bit better when we do a couple of examples. It is used to reverse the effect of an operation and to help solve equations. So, it's technically opposite of each order of operation. So, for example, the opposite of addition is subtraction. So what do you think the opposite of multiplication is? It's division. Now we'll do a couple of examples. So we'll do this one example together. 2x plus 3 equals 7. We'll do this step by step. So step 1 is to isolate the term with the variable. You need to get x by itself onto one side of the equation. So to do that, we have to subtract 3 from both sides of the equation. So 2x remains the same, but you would remove the 3 to make sure that you get it by itself. So once you do that, the 3 gets cancelled out from one side, and you would have 7 take away 3. 2x take away, what's 7 times 3? 7 take away 3. It equals to 4. Now, once you have this one number by itself, you have to take this one to the other side. And what was joining the 2 and the x together? Multiplication. So what's the opposite of multiplication? With division. Remember, the equal sign is always something that would be bringing the opposites. So once you move from left to right, it would be opposite, and that goes for the right to left. So once you take one operation from one side to the other and it crosses the equal sign, you do the opposite operation. So here, if it's joined by multiplication and you cross the equal sign, it becomes a division. So 4 divided by 2 equals x equals 2. So it should look, for this step, it should look very similar to this. So to get the x by itself, it has to divide by both sides of the equation by 2. So the 2's get cancelled out, and that gives you x by itself, which equals x equals to 4 divided by 2. And what's 4 divided by 2? Equals to 2. So the solution is 2. And an extra step that you could do is write therefore. So 3 dots in a triangle form is also known as a therefore in maths. So therefore x equals 2, and that is your sentence, final sentence of maths. Let's do another example. We have 3x take away 5 equals 10. Now remember, your first step is to get 5 on one side. So you would do is 3x. Now keep the order of operation in mind. If it's negative, and once you cross the equal sign, it becomes positive. So once you take the negative to the right, it becomes positive. So it would be 3x plus 10, 3x equals to 10, add 5. Now this will remain as 3x till we get the final steps. Now what's 10 plus 5? 15, right? So you've gotten your x so close to by itself, right? You have one more step, and it's to get this two separated. Remember how we said that the number and the letter are joined by multiplication? Once we cross the division, it's the equal sign, it becomes division. So you'll have 3x divided by 3 and 15 divided by 3. Now 3's get cancelled out, which leaves the x by itself, and 15 divided by 3. Now what's 15 divided by 3? It's 5. So that's the example that you could think of. Now remember, these are the fundamentals of the equations. Now the constant is a term that doesn't contain any variables. It's a fixed number. Now the value of the constant will remain the same regardless of the variable's value. The coefficient is the number that is being multiplied by the variable in the equation. In other words, it's a number that's attached by a letter. And these are things that you should be revisiting and remembering. And we've done a couple of examples in the previous slides. Now remember, this is the checklist that you should follow or keep in handy for a test. The checklist. Isolate the variable, simplify both sides, solve the variable, and write the concluding sentence or statement. And when I refer to concluding statement, remember it's the 3 dots in the triangle, which also is known as therefore. Instead of writing this word, they give you an easier diagram to draw so that you don't have to write something lengthy, and it's easier because we're not in English, we're in maths. And everything wants to be, and in maths we want to do everything the fastest way possible. Now, real world applications. Now, linear equations aren't just theoretical. They have real world applications in fields like economics, engineering, and science. Understanding how to model situations with linear equations allow us for a better decision making and problem solving in everyday life. Now we'll continue doing some examples. Now example 1.1. So solve for x, and a lot of questions will be phrased as solve for x, solve for y, solve for any letter that is in the question. So now your question is 2x plus 3 equals to 11. Now remember, you have to get the x by itself. 2x, mind you have to get 3 to the other side, right? So what's opposite of positive? It's negative, right? So you have to take away 3 from 11. And remember, you have to get the x by itself. So 2x equals 11 take away 3. So it would be 11 take away 3 equals to 8. And remember what we have to do here? Remember how these two are joined by a multiplication? Once the 2 goes from one side to the other, crossing the equal sign, it becomes the opposite operation, which is also known as inverse operation, which becomes division. So remember, 2x divided by 2 equals to 8 divided by 2. The 2's get cancelled out, leaving x by itself. And 8 divided by 2 is what? 4. So, your answer is 4. And remember, your teacher might want you to write the concluding statement, which is therefore x equals to 4. Now here's an explanation or simplified explanation of example 1.1. So to solve equation 2x plus 3 equals 11, first you subtract 3 from both sides, yielding to 2x equals 8. Then you divide both sides by 2 to find x. Thus, x equals to 4. Now we'll do this other equation. It's a little different this time. This time, the order of operation is negative. Now, what do we have to do here? Now, 3x take away 5 equals 16. Now, remember, if this is what we have to get to the other side, what is the opposite of negative? It's positive, right? So, we have to take 3x and move the negative 5 to the other side. 16 take away 5. Not take away, you're adding it. What's the opposite of take away? You're adding it. And make sure you be careful with mistakes with these equations. Sometimes you can get easily mistaken with the order of operations. Now, the opposite of negative is positive, right? So once you move from one side of the equal sign that is negative, move it to the other side, it's positive, right? So you have 3x equals to 16 plus 5. Now, 16 plus 5 is 21. Remember, to get the 3 by itself away from the joined x through multiplication, you have to cancel them out. And how do you do that? You divide, right? Now, you have to divide both sides. Now, once you divide 3x by 3, 3's get cancelled out and leave the x by itself. And 21 divided by 3 is what? 7. Therefore, the answer for 3x take away 5 equals to 16. Your x is 7. And this is the explanation for example 2.1. To solve for x in equation 3x take away 5 equals 16, first add 5 to both sides, which is 3x plus 5, or add 5 to both sides, which gives you 3x equals to 21. Then you divide by 3x and 7, or equals to 7, which gives you your solution to 7. Now this is a little bit harder, but we could still do it, right? So you have 4x, negative 4x. Remember that. And you have your multiplication between the x and the negative 4, which equals 16. Now negative 4x equals to 16. Now remember, you have 2. This is joined by multiplication. You have to get divided, right? To get the x by itself. Now 16 divided by negative 4. Remember, the negative 4 stays the same. Now negative 4. And to get x by itself, you have to cancel them out. So negative 4 and negative 4 gets cancelled out, leaving x by itself. Now 16 divided by negative 4 is negative 4. Now remember, this is something that you would have to keep in mind. So, in your maths, you have to remember this part, which becomes really, really important. And don't forget, you also have to remember the following. These are really vital, especially when it comes to order of operations and when it comes to solving algebra. Now, this is the explanation. To isolate x, you have to get rid of negative 4. To do this, you have to divide both sides of the equation by negative 4. This is a inverse operation of multiplication. And I'll be writing the division step right here. So your resulting answer will be in positive. Remember, two negative numbers give you a positive number, which equals to 4. Now try and do this equation by yourself. Make sure you pause through this part to allow yourself to give this question a go by yourself. I will do the equation or the solving for this following question. So here's the summary. Linear equations are equations where the variable is raised to the power. The goal is to isolate the variable, usually x, to solve for its value. Now, key takeaways is that step 1, isolate the variable using inverse operations, so subtract or add items or terms on both sides. Step 2, simplify both sides of the equation to ensure like terms are combined. Now, one thing that I didn't mention is like terms. Like terms are terms that are the same or very similar that you could join together and subtract together. When it's not like terms, they cannot be added together, subtracted together. It cannot be done the same. Whereas like terms, you could do any of the operations together. Step 3, solve for variable by dividing or multiply to get its value. To check your solution, always substitute the value of x that you've found back into the original equation to verify if it works. Now, conclusion and the next steps. Congratulations on unlocking the secrets of linear equations. By mastering these concepts, you can tackle more complex mathematical challenges. Continue practicing and remember that each of these questions is a stepping stone to a greater understanding of mathematics. Now that you've gotten a grasp of what linear equations are and how to solve them, you'll be able to graph them in the next couple of times, or even the next couple lessons.